Hey there, in this video we're going to look at the two types of loops that there are in Python. So we've previously looked at how you can take different paths through your code depending on if a statement is true or not. And one of those paths might be I want to do something over and over and over again. It might be that I want to iterate on an equation trying to find a solution. That's a pretty common thing that we'll be doing in this course. And so let's build on the fact that we just talked about if statements and look at a closely related kind of loop called the while loop. So with the if statement, it was if condition do this. With the while loop, it's if condition repeat this. So let's make this an actual Python code. Let's start out with, say, x equals 0. And as long as x is less than 10, I want to do something. And print x, and notice just like the if statement, I have to have this indentation here to make it part of the while loop. If I go back to my outer indentation, I'm outside the loop. So if I'm back here, that's outside the loop. Print x. Now I don't want to run this just yet, because what will happen here is line 1 says x is 0. We'll check, is 0 less than 10? Yep. Okay, let's print x. X is 0. And now it goes back here and it checks again. Is x less than 10? It still is. It's still 0. Print it. And that's just going to happen forever and ever and ever. So let's suppose we foolishly run that anyway. Now we have endless zeros. Oh no, what do? Click outside the cell and type II. And that will interrupt the kernel. It'll say, hey, stop. You could also go up to the menu here and interrupt kernel. Let's fix this issue. So what I need to do is update the value of x. I can do that with let x be equal to its previous value plus 1 more. Okay, this is not an algebraic equation. I'm not trying to solve x algebraically here. I'm saying assign the name x to whatever the value of x currently is plus 1 more. So as we go through this, the first time through, x is equal to 0, and this is going to evaluate the new value of x is equal to 0 plus 1. So now x is 1. The next time through, x will be 2, and so on. Each time it's checking, hey, is that number less than 10? If it is, keep going. So when I run this code, it doesn't run forever anymore. It's going to print out x each time. So the first time x is 0, then it's 1, then it's 2, all the way up till 9. And then, so right now at this line, x is 9. The next line says now x is equal to 10. Comes back up here. Is 10 less than 10? No, 10 is not less than 10. So the while loop does not execute, and we continue on for our program. Just to prove that we've continued on through it, we could add a statement here that's, say print done. Okay, so we're done with our loop. So this style of while loop is pretty formulaic, and there's actually a better way to do it, and that's using the other kind of loop called a for loop. You see, the issue here is we always have to, it's not just the while, but we also have to start with some kind of starting value for our variable, and we have to update it. And, that kind of seems like, well, if we're always doing the same thing, surely there's a more efficient way. And there is. That's called the for loop. The way the for loop works is going to be, we're going to go through a sequence. So for x in some kind of, the simplest of these would be for x in some kind of list. So our list could be 1, 2, 3, 4, 5. For x in L, do something. In this case, we could just be print x. So the way we should interpret this is x is going to 1 by 1 be every value that was in the list L. So it's going to start out being 1, then 2, 3, 4, 5. And so that's what it's going to print, 1, 2, 3, 4, 5. Now if you're thinking, but wait, I have to write a list for everything? Like what if I want 1,000 things? I don't want to type 1,000 numbers. Well, you don't have to type 1,000 numbers. There's a shortcut for this. There is a special function called range that creates a list for us. So technically it creates a thing called a generator. The difference is the list has to reserve memory for everything in it. The generator doesn't have to do that. It just generates the values. But it's like a special function here. So, and the name of it is range. If I want to do for x in range 5, print x. Now we have code that's going to print up to whatever number we put in here. It's going to start at 0. And that's actually pretty handy for us because when we learn about indexing, the index of lists and tuples and later on arrays, they start at 0. Most counting and programming starts at 0. So it's going to start at 0 and go up until not quite 5. We're going to get a total of 5 things printed, but we're not going to actually see the number 5. let's say I want to actually print 1 through 5. If we look over here at the help, we can see we've got a few different ways to format range. We could just do stop, or we can do start stop and then optionally a step size. So thinking about that start, I want to start at 1. Okay, so 1 through 5, let's see what that does. 1, 2, 3, 4. Oh, I didn't get the 5. Why? Because it stops right before stop. It's kind of like my while loop here. My while loop didn't print 10. It's checking against 10 and it stops before 10. So if I actually wanted to print 1 through 5, in my range statement I'd have 1, 6. That would give me 1 through 5. So a feature we can use with either while loops or for loops are the break and continue statements. And the meaning of break is I want to escape from the loop no matter what my values are. I want to get out of here. And the meaning of continue is I want to skip the rest of the loop and continue on. I still want to be in the loop, I just want to skip what follows. So we can do these with while loops or for loops. Let's say we, just for example, we'll do a for loop just like we had before. So we'll do x in range, let's do range 10. Print x. Okay, so this is your regular loop. It just prints 10 values 0 through 9. Now, let's use a break statement. I don't want to just have break in here, because if I just have break in here, what's going to happen is the first time through the loop, it's going to hit break and it's going to escape, and it won't print anything at all. To use break or continue, you almost always have to use an if statement. So let's say if x is equal to 4, I want to break. Now this is kind of silly code. Why would I code it this way? But just for the sake of example, what will happen is x will be 0, 1, 2, 3, and then when it's 4, it says get out of here, don't do anything else. So I'm only going to print 0, 1, 2, 3. As soon as x was 4, it got out of here before it could print. It's a little bit different than if we do continue. If I do continue, it says if x is ever 4, immediately go back up to the beginning of the loop. Don't do the next thing. So it's going to print 0, 1, 2, 3. 4 is missing because that's when the continue triggered, and it continued the loop at 5, 6, 7, 8, 9. We don't use continue very much in this class. I don't know if I can say never ever, but it'd be pretty unusual. We use break sometimes as a way to get out of our loop. More so with while loops than with for loops. Another style of writing your while loop is you can write it like this. You could do while true, because true is always true. This is an infinite loop. It'll go forever. Some stuff happens and you might have a, you know, if x is 0, something has happened, x is 0, then you can get out of your loop. That's another style for writing the loops. It's dangerous though, because if this condition is never reached, it'll just run forever and ever and ever. Another place you can use break is in the context of a for loop. So in particular, let's say we have something that should happen quickly. We're doing some kind of iterative calculation. It should be done in say like 100 steps. Just to be sure, we'll let it go for 1,000. But if it's gone more than 1,000 steps, it's definitely broken, and then I want to get out of my loop so my code isn't running forever. That can be the kind of case where we might want to do a break statement. So like, let's say it's a calculation where x should eventually become 0, and then we want to get out of there. But if we didn't, you know, we'd run only 1,000 steps, and then we could do something like print some kind of value if x was ever reached 1,000. So let's try a quick example. So if we look at the infinite series, 1 plus 1/2 plus 1/4 plus 1/8 plus a 16th, and then so on and so on and so on, we will eventually get 2 if we add these all together infinitely far out. So what we're doing is we are doing, if we look at the n term here, that would be like 1 divided by 2 to the power n. And so let's see how close we get after doing, let's say 10 terms, how close we can get to 2. So we could do this with a while loop or a for loop. I know how many steps I want to take, so in that case, that tells me I'd like to use a for loop. So for loops are good when you know how many steps you want to take, while loops when you're not sure. You're just looking for some condition to be true. So we'll do a for loop and we'll make n be the variable in our loop, and we'll take it through range 10. That'll give me 10 steps. And then as we go through, I want to be incrementing some kind of sum. So we'll create a variable for the sum. We'll start it at 0. And then we're going to take our sum here and we're going to add values to it. So we're going to say sum is equal to its old value, and then we're going to add on 1 divided by 2 to the power n. Whenever you have a numerator or denominator in your code, it is a really good idea to put your denominator in parentheses. It's true that Python will do this just fine because order of operations says raise to the power n and then divide. But you really want to get in this habit. I can't tell you how many times I've seen code like this. So let's say I wanted to do a sort of a related calculation, 2 times n. That is not at all the same thing as writing 1 divided by 2 times n. That's different. In the first case, it does what you want. In the second case, order of operations says calculate 1/2 multiplied by n, and those are different. Anyway, it comes to mind right now, so I wanted to warn you about that. Anyway, with the example we have here, we've calculated our sum, and now let's print it out. Okay, and so that's the first 10 terms in our sequence. You can see we're getting pretty close to the value of 2 already. There's one improvement we can make. And if we look here, sum equals sum plus something. We saw that way at the beginning here with x equals x plus something. That happens pretty common. So there is a shortcut notation for that, which is to use plus equals. So x plus equals 1 is the same thing as, right here, the same thing as x equals x plus 1. So read this as increment. So increment by 1. We could also do increment by 2. In fact, we can use any of our algebra operations here. We can multiply by 2. We could divide by 2. We can even like modulo 2. Most common though would be your plus, specifically your plus equals 1. So we can use that little shortcut notation here or in that very first cell with our while loop. And if we run that, we get exactly the same result with just a little bit less typing. Okay, so that's a good place to stop. So we've looked at while loops and for loops. The main use cases for them being the while loop when you're not sure when the condition is going to be met. You're just running code until a condition is met, whereas the for loop takes a certain number of steps and you have some idea of how many steps, well, you know exactly how many steps you want to do, and you just want to do something for each thing, whether it be a variable counting up or a variable going through the elements of a list.